A-level mechanics, we're going to look at the equations of motion for constant acceleration. These are often called the SUVAT equations. Well, let's see what we mean by that. When solving a problem involving an object moving with constant acceleration, we use the following notation. We use the letter small a to represent the acceleration, t to represent the time taken, that is the time for which the object is accelerating, u, the initial velocity, that's the velocity the particle is moving at the start of time t, and v, the final velocity, the velocity the particle is moving at the end of time t. And finally, s is the displacement. This is the displacement of the particle during the time period t. Now the displacement is the distance between the start position and the final position. It's not necessarily the total distance travelled. You'll notice that we've used 5 letters, S, U, V, A and T. That spells out SUVAT, hence we have the name. Now the terms acceleration, velocity and displacement are vectors, and these can be in any direction. However, to simplify things, we'll initially consider motion only along a straight line. Now we can represent this as a velocity time graph, as seen below. The acceleration is the gradient of the graph. Now to find the gradient of the graph, we have to draw a triangle under the graph, and then work out the height of the triangle over the base of the triangle. Now the height of the triangle is v minus u, and the base of the triangle is the time t. So we have the acceleration is v minus u over t, and if we multiply both sides by the time t, we have at equals v minus u. In other words, v equals u plus at. Now that's the first of our SUVAT equations. Now we know the distance covered on a velocity time graph is the area under the graph. And we can find the area because we've got a trapezium. Now the area of a trapezium is a half the top plus the base times the height. However, the trapezium is on its side, so the top is the vertical line going up to u, and the base is the vertical line going up to v. And so we have s, the distance, is equal to u plus v over 2 times t. Now that's our second SUVAT equation. Now we can substitute v from 1 into 2, and that gives us s equals u plus at all over 2 times t. And so s is a half of 2u plus at all times t, which gives s equals ut plus a half at squared. And that's our third SUVAT equation. Now we can also substitute u from 1 into 2, and we've got u equals v minus at, so s is equal to v minus at plus v all over 2 times t, which simplifies to s equals a half into 2v minus at all times t, or s equals vt minus a half at squared. And that's our fourth equation. Now actually most books leave that equation out, but really you should include it. There are 5 unknowns, each equation involves 4 letters, and so in each case there's 1 letter left out, and so there are 5 equations. And finally from 1 we've got v minus u equals at, and from 2 v plus u times t equals 2s. So if we multiply, we get v minus u times v plus u times t equals at times 2s. And we can cancel the t from both sides and expand the brackets. Now this is the difference of 2 squareds, so we have v squared minus u squared equals 2as, or v squared equals u squared plus 2as. And this gives us the 5 equations known as the SUVAT equations. And you should learn these. They're very useful. They may be given in the exam, but you should be able to rattle them off quickly when you need them. So the one missing the letter S is v equals u plus at. The one missing the letter A is s equals u plus v over 2 times t. The one missing the letter v is s equals ut plus a half at squared. The one missing the letter u is s equals vt minus a half at squared. And the one missing the letter t is v squared equals u squared plus 2as. Okay, let's have a look at some problems involving the SUVAT equations. Now, first of all, it's handy to have the SUVAT equations in front of us. Each of the equations uses 4 of the 5 letters, and the letter in the bracket is the letter missing from the equation. Each question will involve 4 letters. 3 will be given and 1 will be asked. If we find the letter that's missing, we can tell which equation to use. Now in question A, we're asked to find v, given that u is equal to 3, a is equal to 2.5, and t is equal to 8. So to solve it, we're given the letters u, a, t, and v, and the missing letter is s, which means we want to use the equation v equals u plus at. So substituting in, we get v is equal to 3 plus 2.5 times 8, which works out to be 23. So our answer is v equals 23 meters per second. Now in part B, we're asked, find s, given that u is equal to 3, a is equal to 2.5, and t is equal to 8. So, writing those down, we notice the letter v is missing. So the equation we want is s equals ut plus a half at squared. And substituting in the numbers, that gives us s is equal to 3 times 8 plus a half times 2.5 times 8 squared, which is 24 plus 80, and so our answer is the distance travelled s is 104 metres. In part C, we're asked to find the acceleration a, given that u, the initial speed, is 3 metres per second, v is 31 metres per second, and t is 16 seconds. Well, if we write those down, we realise that the letter s is missing, which means we're going to use the equation v equals u plus at. And substituting in the letters that we know, v is 31, u is 3, t is 16, and that gives us 31 equals 3 plus 16a. In other words, 16a is equal to 28, and if we divide by 16, a is 1.75. And so we have the acceleration is equal to 1.75 meters per second squared. In part D, we're asked to find u, given that v is 12, a is 3, and s is 18. Now if we list those down, we find that the missing letter is t, and so we need to use the equation v squared equals u squared plus 2as. Now, if we substitute the numbers in, that gives us 12 squared equals u squared plus 2 times 3 times 18, or 144 is u squared plus 108, and if we subtract the 108, we get u squared is equal to 36. Which means u could be plus or minus 6. Now because we're working with velocities, u can be a negative number. So we have 2 possible answers. U is equal to 6 meters per second, or u is equal to minus 6 meters per second. And in part E, we're asked to find t, given that u is 28, a is minus 8, and s is 45. So if we list those down, we find the missing letter is v, and so we're going to use the equation s equals ut plus a half at squared. Substituting in gives us 45 equals 28t plus a half times minus 8 times t squared. Now that simplifies to 4t squared minus 28t plus 45 is 0, which is a quadratic equation. We can solve that by either using the formula or factorising. Now this one does factorise as 2t minus 9 into 2t minus 5 equals 0. So that tells us t is 9 over 2, or t is 5/2. So our answer is the time is 4.5 seconds or 2.5 seconds. Let's have a look at another example, example 2. A train accelerates at a constant rate of 1.25 meters per second squared. It then travels 418.5 meters in the next 18 seconds. In part A, we're asked to find its initial speed. Well, to solve this, we look at what we've been given and what we want. We're given that A is 1.25, S is equal to 418.5, and T is equal to 18. We want to work out what is U. So the missing letter is V. Now that means we're going to use the equation S equals UT plus a half AT squared, and we simply substitute in the numbers that we have. So S is 418.5, and then UT is 18U, plus a half A, which is 1.25, times T squared, which is 18 squared. Now that simplifies to 418.5 equals 18U plus 202.5, or 18U is equal to 216, which means U is 12. So our answer is the initial speed U is 12 meters per second. In part B, we're asked to find the final velocity. Well, we have A is equal to 1.25, S is equal to 418.5, and T is 18, but this time we're trying to find V, so the missing letter is U. So we're going to use the equation S equals Vt minus a half AT squared. Now S is 418.5, T is 18, so 418.5 is equal to 18V minus a half times 1.25 times 18 squared, which gives us 418.5 is equal to 18V minus 202.5, or 18V is equal to 621. Dividing by 18, we get V is 34.5, and so the final velocity V is 34.5 meters per second. In example 3, we're told a car is accelerating at a constant rate. It covers 12 meters in 4 seconds, and then a further 42 meters in the next 6 seconds. Find its acceleration and its initial speed. Now this problem is a little bit different to the ones we've had so far because it's got 2 parts to it, and in each part we're only told 2 facts. So if we let the initial velocity be u and the acceleration be a, we don't know either of those, but we do know for the first part of the journey s is 12 and t is 4. Now, using s equals ut plus a half at squared, that gives us 12 equals 4u plus a half times a times 4 squared, which is 12 equals 4u plus 8a, or u is equal to 3 minus 2a. We can call that equation 1. Now for the total journey, the total distance is 12 plus 42, which is 54. And the total time is 4 plus 6, which is 10. So for the total journey, s is 54 and t is 10. And we still have the same initial u. So using, again, s equals ut plus a half at squared, 54 equals 10u plus a half times a times 10 squared. So 10u plus 50a is 54. Now if we call that equation 2, if we substitute 1 into 2, we get 10 into 3 minus 2a plus 50a is equal to 54. In other words, 30 minus 20a plus 50a is 54, and that simplifies to 30a is 24, or a is 0.8 meters per second squared. So our answer for the acceleration is 0.8 meters per second squared. Now going back to equation 1, we've got u equals 3 minus 2a, so u is 3 minus 1.6, or 1.4. And so the initial speed is 1.4 meters per second. Let's look at one more example, example 4. Two cyclists start cycling from rest at the same time. John starts 15 metres behind Peter. John has a constant acceleration of 1.5 metres per second squared, and Peter has a constant acceleration of 1.2 metres per second squared. In part A, we're asked, how far does John have to cycle to catch up with Peter? Well, a diagram helps. Let x be the distance that Peter travels when John catches up with him. Now we can use s equals ut plus a half at squared. So for John, the distance he travels is x plus 15. His initial speed is 0 and his acceleration is 1.5. This means x plus 15 is equal to 0 plus a half times 1.5 times t squared. That is, x plus 15 is equal to 0.75 times t squared. And for Peter, the distance he travels is just x. Again, u is 0 and a is 1.2. So x is equal to 0 plus a half times 1.2 times t squared. That is, x is equal to 0.6 times t squared. So we have two equations. X plus 15 is equal to 0.75 t squared. And the other one, x equals 0.6 t squared. Now if we subtract one from the other, we get 15 equals 0.15 t squared. So t squared is 15 over 0.15, which is 100, and t is the square root of that, which is 10. So in 10 seconds, John travels x plus 15, which is equal to a half times 1.5 times 10 squared, which is 75. So John travels 75 metres. Now in part B it says what speeds are they doing when John overtakes? Well, using v equals u plus at, John's initial speed is 0 and his acceleration is 1.5. They overtake after 10 seconds, so v is 0 plus 1.5 times 10, which is 15 metres per second. And for Peter, u is 0, a is 1.2, and again t is 10, so v equals 0 plus 1.2 times 10, which is 12 metres per second. So we have John has a speed of 15 metres per second and Peter has a speed of 12 metres per second when they overtake.